Hello everyone, I'm Sneha Sathi Pamati, pursuing my master's in the stream of data science at University of North Texas. Today I'm presenting you the paper called Simon, which is an open source knowledge discovery platform. The author described the Simon open source tool in his paper. In biology and medicine, data analysis and knowledge discovery are becoming extremely important. The amount of data in the biomedical areas is always growing, making it challenging to extract insight from data without applying advanced algorithms. So biomedical researchers won't have as much expertise in coding and information extraction from ML algorithms. So for the purpose of enabling the application of 182 machine learning algorithms to highly dimensional biomedical data, author had developed a modular open source software called Simon by evaluating the model in three phases like training, validation, and testing. Simon is designed to have an accurate model prediction while also minimizing overfitting with a user-friendly graphical user interface, standardized patterns, and an automated approach for machine learning and other statistical analysis methods. Simon aids in the identification of the best algorithms and often non-technical and technical researchers with a tool that enables them to spot significant patterns in biomedical data. And Simon also supports cloud processing architecture. Others have also explained about the modes in Simon. There are like two modes, the single mode and the server mode. Well, server mode has an advantage of multi-mode capability. So from the three phases, the training, validating, and testing, actually the data set will be divided into the training data and testing data. So the training data is to train a model how to work and all, and the testing data is to test the model whether it is working correctly or not, and the validation is to validate the model. And it has like cross validation techniques, so it has some numbers which we can select as per the most accuracy and all. And I pretty much understand this algorithm. I'm familiar with machine learning. Machine learning. So I also have done a course in machine learning in my tenure, like during my master's. So the author did a respectable job of outlining the origin of the idea. So let me tell you like from where the idea has come for the author. Over the past several years, due to the technical breakthroughs in genome sequencing, high dimensional flow symmetry, mass similarity, the multi-parameter microscopy, and the amount of complexity of biological data have become increasingly interactable, and it is no longer feasible to extract knowledge without using sophisticated computer algorithms. Therefore, researchers are in need of novel computational approaches that can cope with the complexity and heterogeneity of data in an objective, unbiased way. Machine learning, a subset of artificial intelligence, is a computational approach developed to identify patterns from the data in order to make predictions on new data. ML had been a profound impact on biological research. So that is the area from where it has come. So open source web-based software cloud processing architecture is essential. To address these challenges, the author had developed Simon, a free and open source software for application of ML in life sciences and facilitate production of high-performing ML. Of the total development process. And the author's consideration of the main area is the biomedical field, and identification of a solution, in my opinion, is what makes the paper strong. The key aspect of the study that I found interesting was how the author included his work on several data sets that were used with various algorithms, following the tool's development, and applying dimensionality reduction techniques to the tools from which we may derive the most accuracy would help this paper even more. If I had written this paper, I would have made sure to explain the distinctions between machine learning and statistical programming is also important on different fields. So I have a few questions that I would like to discuss there. The first thing, like while explaining about the training phase, validation phase, and testing phase in an ML algorithm, he told that he has used a tenfold cross validation. And I just have a doubt that how did the author have decided to make 10 cross validations, tenfold cross validations? And also, why did authors use any dimensionality reduction techniques? Or else, if at all he used any dimensionality reduction, why didn't he mention in the paper? And also, how naive bias used on the donors data set or classification of it. Thank you.